And welcome students to our next lesson in encapsulation and inheritance. Let's go ahead and discuss protected and package access. So getting started. You cannot access by name a private instance variable or a private method of the base class within the definition of a derived class. Now there are two classifications of instance variables and methods that allow them to be accessed by name in a derived class. The two classifications are protected access, which always gives access, and package access, which gives access if the derived class is in the same package as the base class. So let's talk about protected access first. If a method or instance variable is modified by protected rather than public or private, then it can be accessed by name. It can either be accessed by name inside of its own class definition. It can be accessed by name inside of any class derived from it. It can be accessed by name in the definition of any class in the same package, even if the class in the same package is not derived from it. However, the caveat is that the protected method or instance variable cannot be accessed by name in any other classes. Thus, if an instance variable marked protect in the class parent and the class child is derived from the class parent, then the instance variable can be accessed by name inside any method definition in the class child. However, in a class that is not in the same package as parent and not derived from parent, it is as if the protected instance variable were private. So let's look at this with an example. Let's consider the class hourly employee that was derived from the base class employee. We were required to use accessor and mutator methods to manipulate the inherited instance variables in the definition of hourly employee. So consider the definition of the toString method, which is repeated here. Right, get name, get date, hire date, wage rate per hour for hours. If the private instance variables name and hire date have been marked protected in the class employee, the definition of toString in the derived class would have been simplified to the following: name plus hire date dot toString plus wage rate plus per hour for hours. That looks kind of like something more that we said you shouldn't do, but it's because, again, it's using protected. Now the protected modifier provides very weak protection compared to the private modifier, because it allows direct access to any program who is willing to go through the bother of defining a suitable derived class. Now, many programming authorities discourage the use of the protected modifier. In fact, very rarely are you going to use protected. You're most likely going to use just public, or you're going to use private. But you need to know about protected because it does exist. Now, instance variables should normally not be marked protected. Either going to be public or they're going to be private. Your methods, on the other hand, you may want to have, occasionally, in a rare situation, marked protected. If you want access intermediate between public and private, so if you want some kind of level where private is not accessible, public is accessible, but you want them to be able to have some level of accessibility, then access described in the next paragraph is often a preferable alternative to that of protected, and that is of package access. You may have noticed that if you forget to place one of the modifiers, public, private, or protected, before an instance variable or method definition, then your class definition will still compile. So if I just put, int x at the top of my class, even though it's not public, it's not private, it's just an instance variable, it's still going to be fine. If you do not place any of these modifiers before an instance variable or method definition, then the instance variable or method can be accessed by name inside the definition of any class in the same package, but not outside the package. So it's almost like it's public. This is called package access, or default access, or friendly access. We're going to use package access as our terminology here to describe this because it's in the package that's in Java. Remember, package, if you're inside of Eclipse, is by default just called default package. We've dealt with working with packages back in programming 1. Now, use package access situations where you have a package of cooperating classes that act as a single encapsulated unit. So, for example, the employee class has a bunch of derived classes that are all technically working collaboratively with the employee class. Now, please note that the package access is more restricted than that of protected access, and that package access gives more control to the programmer defining the classes. If you control the package directory or folder, then you control who's allowed into your package access. And that's the reason why package access is a little bit more strict, because it has to do with directory control. All right, so let's just quick segue here to a quick diagram to kind of give some illustration. So this may help you understand who has access to members with public, private, protected, or package access. So in here I have two classes. Here's A and B, and you can see A has two childs. I have a class C and a class D, and then there's another class over here, class E. Okay. So the diagram tells us who can directly access by name the variables that public, private, protected, and package access. The same rules apply to methods that public, private, protected, and package access. So in here, you can see we have public int variable 1. This is a public variable. I have a protected int variable 2. This is a protected variable. And it's just declared like that. You just put protected from it. If I just put int variable 3, that's considered a package access level. And if I put private int, well, that's the private access level. So pretty much each of these is going from least restrictive to most restrictive. So we just kind of follow that chain down. And if we want to look here at these different classes, we can see how those different variables are accessible from this class. So if you notice, this right here, package some package, includes class A, class B, class C, but it does not include class D or E. So if we look at class B, you can see that class B can access variable 1, variable 2, and variable 3, but it cannot access variable 4. That's because variable 1 is public, variable 2 is protected, and variable 3 is package, and of course B is in the same package. Now it can't access variable 4 because that is a private instance variable. Right? None of these should be able to access, except for A, private instance variable number 4, because private means that it's restricted to that class. Then we go to C. If we look at C, it is exactly the same as B. The only difference between that of A and that of B is that C is a derived class. If you notice, you can see the keyword right here, extends. So C is a derived class. But functionally, in terms of when we talk about access levels here for protected, public, private, and package, C is the same as B. Now we go outside the package to D and E, and you'll see that D extends A, which means it's a derived class. However, it's not within inside of the package. All right, so therefore, because it's not inside the package, it can access the public variables, so variable 1, and it can access the protected variables because it's a derived class. However, because it's outside of the package, it can't access variable 3 because variable 3 is restricted to that package level, and that's why it's more restricted. Variable 4 again can't access it because it's private. And we look at E. E has the least amount of access because it's outside the package, and it is not derived from A. Right? Now, just some quick notes in here. You'll see that it says in this diagram, access means access directly. That means access by name. So that means, for example, if this was public int variable 1, that means over here I want to say like variable 1, maybe I just want to do a system out of print line of it. So system out of print line variable 1. That's what access means. I can use that variable. All right. This right here says a line from one class to another means the lower class is derived, which is already mentioned. So you see A and B, or A extends to C and D. And if the instant variables are replaced by methods, the same access rules apply. So right now in this example, we use variables, but if we were to switch those variables out for methods, like public methods, protected methods, package methods, and private methods, everything that we see here in this diagram for variables would apply to the methods as well. All right, quick pitfall to note for you, which is forgetting about the default package, which is very, very crucial here when we start talking about package access. When it comes to considering package access, don't forget about the default package. The default package is what we use for most of our programming. All right. It's like, hey, we fire up Eclipse, make a program, boop, there it is, and we kind of forget about the packaging. However, recall that all the classes in your current directory that do not belong to some other package belong to an unnamed package called the default package, unless you otherwise name it. So if a class in your current directory is not in any other package, then it has to belong to the default package. If an instance variable method has package access, then the instance variable or method can be accessed by name, the definition of any other class within inside the default package. All right, it's going to function just like any other package, but because it's in the default, it's going to follow that. All right, and that's going to put a wrap on today's lesson, folks. So we will see you next time.